Hello everyone, I wanted to go over our notes for rationalizing the denominator. So our essential question, this is an important question for you guys to be writing down. What is the not allowed in the denominator and what do you do to resolve the problem? You're rationalizing the denominator. If the final solution has a radical in the denominator, this is not allowed. Remember, the denominator is the bottom part of the fraction. And our steps to rationalizing the denominator, you want to simplify the fraction as much as possible. We can also check for things to divide out first, or we can also square root or cube root. And I'm going to actually specify when the right time would be to simplify on this and versus just taking the radical. Step 2, if there is a radical in the denominator, you're going to multiply the numerator and the denominator, top and bottom of the fraction, by the radical only. You're going to simplify the fraction completely at the end, and our first example to go over this is, we're going to see that we have 2 root 3 on the bottom. So we can't simplify our fraction or anything here, we can't take the square root of 3, so we do have a radical in our denominator, so that means we have to multiply both the numerator and the denominator by the square root of 3. So we're going to multiply straight across, just like we would multiplying regular fractions, and we have 2 root 3 divided by, and then remember root 3 times 3, when we multiply our radicals, we end up getting 3 times 3, which is 9, but the square root of 9 is actually 3. So we want to simplify that, and we want to double check that our coefficients, this 2 and the 3 outside, these cannot actually simplify, the 2/3. This one and this one can also not simplify because one is outside the radical and the one is inside the radical. Just to show you guys another thing for what this means, the root 3 times root 3. We also have root 3 squared. So remember this, I had mentioned in the notes prior that the square root and the squared are actually inverse operations of each other and actually cancel each other out. So we're left with just the square root of 3, which is actually 3, and then again here, this situation, the root and the exponent actually cancel each other out. So let me show you another example here. We have the square root of 4/3, and again, this is just telling me to take the square root of 4 and take the square root of 3. Well, I know that the square root of 4 is 2, but we can't take the square root of 3, so we're actually right back to where we were in our previous example. So now I get 2/3 and, 2 root 3, and then again my square root 3 times square root 3 is the square root of 9, but the square root of 9 is 3. Again, we can't simplify this 3 and this 3 because one's inside the radical, the other is outside the radical. Our example number 3, we're going to add some variables into here. So let's go ahead and do the square root of 3x squared y cubed divided by 4 square root of 5xy to the third. So let's go through and see if we can simplify. So let's look at the coefficients. We only have a 1 and a 4, can't simplify that. Our 3 and our 5, we are unable to simplify that. So our x's, we actually do have 2 x's on the top and 1 on the bottom, which means we have 1 x left on the top. So I'm going to go ahead and rewrite this radical with 1 x on the top. My 3 I wasn't able to simplify in there. My y's, I have 3 on top and 3 on bottom. So they actually all divide out, so I'm just left with a 3x on my numerator. No more y's, this 4 stays out, and I only have a square root of 5 here. So all of those cancel out. I'm unable to simplify anything else in my fraction, so now I have to multiply by the radical only, because I have a radical inside or on the denominator of my fraction, and you only multiply by the radical. So I'm going to multiply by the square root of 5, both the numerator and the denominator. And now I'm going to multiply straight across like I would normally. So they're both in the radical. We're going to multiply the 3 and the 5. So we have 15, and then x. And then we have our 4 and then we only get to multiply the things inside the radical. So if we have the 5 times 5, it's the square root of 25, but then the actual square root of 25 is 5. So we have 15x, this stays the same, 4 square root of 5, or 25 is 5, and you just multiply those. The operation that's going on between that is multiplication. And now we're going to take the square root of 15x, and 4 times 5 was 20. We are unable to simplify the 15 and 20 because the 20 is outside the radical and the 15 is inside the radical. So this is my final irrational solution. For example 4, we're going to get into cubed roots. So I'm going to go ahead and do 8 divided by 3, and we're going to do the cubed root of 2. So this one's going to be a little different. We are working with cubed roots. So back here we were trying to make our numbers perfect squares. So we did square root 5 times square root 5. That made us a perfect square of the 25. We were able to take the square root of 25, which got us to be 5. So now that we're on cubed roots, we now have to figure out what's going to make it a perfect cubed root. So again, first we're going to see if we can simplify our fractions. We are unable to simplify this 8 and 2 because the 2 is in the radical and the 8 is outside. So I'm going to go ahead and realize that, okay, I still have this radical in my denominator here. So now I need to actually multiply by the radical in our denominator. So we will multiply both the numerator and the denominator by a cubed root, and we have to try and figure out what number will 2 times 2 times 2 be, which is going to be 8. So how many more 2's do we need in order to get the cubed root of 8? We already have 1 2, so we need 2 more 2's, and what's 2 times 2? We get 4 and 4. So just kind of maybe sit back on this example and watch it first, you guys. So then now, when I get the 8 multiplied by the cubed root of 4, this is just going to stay as my coefficient. This is my radical. And then, when we do this, we see that we have 3 as our coefficient, the cubed root. We're allowed to multiply the radicands. 2 times 4 is 8. And now we can actually take the cubed root of 8. It's 2 times 2 times 2. So now I have 3 and times 2, which is the cubed root of 8. So my last step is just to multiply my denominator. Before we actually do that, we can simplify because our 8 is outside the coefficient and this 2 is outside. So I know that 2 goes into 2 one time, and I know that 2 goes into 8 4 times. So now I have my simplified 4 cubed root of 4, and 3 times 1 is just 3. So now I'm unable to multiply or to simplify that 4 outside the coefficient and the 3 outside the outside the radical, and this is my final solution. We are going to do another example of this one because those are a little bit more difficult to actually visualize and see. So let's try it with 1 divided by cubed root of 5. So again, I cannot simplify anything in my fractions. I need to now multiply by whatever is going to make it a perfect cube. So 5 times 5 times 5. I only need 2 more 5, so 5 times 5 is 25, because I already have one of them. And now, if I remember, 25 is a perfect square, but not a perfect cube. So now I'm going to do 1 times the cubed root of 25, which I have here. And then we are going to do 5 times 25. I'm going to get the cubed root of 125. So that means that if we have the cubed root of 125, that is actually 5 times 5 times 5. Yay, we used the same number 3 times, multiplied by itself. And that means that 5 is our actual cubed root of 125. So that is our final solution for this one. Alright, let's do one more of those cubed roots, just because it is a little confusing. So, negative 10 divided by 2 cubed root of 4. And we are going to simplify our fraction first. So I see that I have a 10 up here. I'm going to cross that out and put a 5 because it's this 2. So now I have a negative 5. I just like simplifying before you guys because then your numbers don't get super huge when you're multiplying by large numbers. So now I have negative 5, and then we have the cubed root of 4. So, well, cubed root of 4, I know that 8 was my perfect square. So I know that, or my perfect cube. So if I have my 2 times 2, that's already 4. I'm actually only missing one more 2. So now I'm going to multiply by the cubed root of 2 and the cubed root of 2. So now I just multiply straight across, negative 5 cubed root of 2. And then when I do 4 times 2, I get my cubed root of 8. If you guys are already getting this, you don't have to be writing that cubed root of 8 because we already know that my denominator is going to be 2 because we figured out that's the next perfect cube. And then I have my negative 5 cubed root 2. Again, I cannot simplify the radical, the 2 in the radical and outside because they are opposite. Bottom 2 is on the outside, inner 2 is on the inner side of the radical. Alright, you guys, I will see you in class. We'll go over a few more examples. Thanks.